on in the unit. But what we do today is not on the quiz, but I am going to move on. So it's not a review day. So this is about as much as the review as you're going to get. Let me just take a quick peek, see how many points are going to be on this thing. Okay, it's a short quiz, 27 points. All right, 27 points. Here's what you can expect. Make sure we know 3 methods of proving triangles similar. I know most of you just think angle, angle, but yeah, that's the way we do it on a statement's reasons, but there's actually others. All right, so yes, we do have angle, angle, but remember, we also have side, side, side similarity. And that, it's one thing to memorize what the method is. It's another thing. Do you even know what the S's mean? Because it doesn't mean the sides are congruent. What does it mean? What's the S? What do the S's mean? That doesn't mean the sides are equal. Sides are in the same ratio. So you're going to have to take a look. All right, is 4 over 12, is that equal to 1 over 3? Is that equal to 2 over 6? Okay, that's side, side, side. And you're going to have to make these up based on the diagram. And then there's the third method, which is side angle side similarity. The angles are congruent. Again, what about the sides? They're in the same ratio. You need the ability to test that, because I'm going to give you a diagram. I'm going to put some labels and lengths on the sides and say, are these similar? If they are, by what reason? So be ready for that. Okay, please be ready for that. What else do I have on here? All right, this isn't a shock. Factoring quadratic formula. I'll give you the quadratic formula tomorrow. No need to memorize it. Build your own proportion. Cross multiply. Use one of the 2 to solve it. It's just exactly what we've been doing in the homework the last 2 nights. Build the proportion off the diagram. Cross multiply. Use one of the 2 to solve for x. And also remember, possibility of rejection. Maybe. Possibility of rejection if you get a negative side length. The proof, one proof, CSSTP, what you did last night. That's what I'm telling you right now, it's going to be CSSTP. All right, that's the one proof on there tomorrow. I'm going to keep going here. There's a ton of this, a ton. Create your own proportion and solve. I'm going to give you a diagram. Label some of the sides. You know the triangles are similar. What's this missing value? And what I'm talking about is one where you don't need to use quadratic formula or factoring. This is just simple algebra, move the numbers to one side, variables to the other. But there is a ton of this, where you have to create your own proportion and match up the sides. And then the final thing I want to just go over is if 2 triangles are similar, then what's true? So you know 2 triangles are similar. What's true about them?
Angles are similar.
No. Angles can't be similar. That's impossible. That doesn't make any sense that angles are similar. Angles are congruent. Corresponding angles congruent. What else is true? Zach?
All sides are in the same ratio.
Corresponding sides in the same ratio. Yep. Yep. And one other thing I'll pop on here that we've done. If 2 triangles are congruent, the perimeter ratio is the same as what? We did that one time and on homework. The ratio of the perimeters is the same ratio as the side ratio. Yep. All right. Anything you want to throw by me right now before we move on? Yep, Via?
What's Can you do it a lot? Can you tell me what C is supposed to be? What's number 5?
So what I'm saying is, here's what I'm saying. Two triangles. They're similar to each other, so I got to tell you that they're similar. Let's see, 6, 8, 11. And all I'm going to tell you here, the smallest side on this one is 2. What's the perimeter of that one? Okay. So what you can say is, all right, well, I know 6 and 2 match up. They're the two smallest sides. 6 over 2 is the same ratio the perimeters are in. Can I find the perimeter with the side of 6? I just add them up. What's that? 14 and 11, 25. That's what I mean by the side ratio is the same as the perimeter ratio. Okay?
How come we got 25 out there?
25 is the perimeter of this triangle. Okay? So ratio of the two sides that I know, 6 and 2, is the same as the ratio of their perimeters. Okay? Anything else? Okay, so tomorrow I'll go over the homework, answer questions, check it. Boom, we get right into the quiz. And I'll have the quadratic formula for you. Everything else on your own. I'll be here today after school if you want to sit down, do factoring, quadratic formula, anything you guys want, I'll be here. All right? All right, let's move on then. Let's move on to today's stuff. It's quick notes today. Quick notes. 2 proofs and a lot of practice from you guys. 2 proofs. We're going to take our proofs right now and make them one step longer. So what have we done? Angle, angle. What's right after we prove the triangle similar? CSSTP. And then I'm going to take it one step more today, and then that's it as far as this unit goes. And good news, we're not doing proofs in the next unit. So this is the last time we'll do proofs for a while. All right, for a while. I know I'm sure that makes some of you disappointed. All right, so if I gave you guys this, 4 over x equals, let's say, 12 over 10. And I said solve for x. What's your move? Cross multiply. All right, a lot of you would do, hey, 4 times 10, right? All I'm going to do today is put some names to that. Everyone see where the 4 and the 10 are? In a proportion, those spots in particular have a name. They're called the extremes of a proportion. All right, those are called the extremes. And then you would go ahead and cross multiply the x and the 12. Those 2 spots have names. Whatever values are in there, those are called the means of a proportion. The means. The extremes going this way, the means going this way. If you want a little, it's very, very corny, but this is how I always remembered it, that these were the extremes. As I'm going left to right, does everyone see I'm going downhill? Everyone see I'm going downhill as I go left to right with the extremes? So I think of extreme downhill skiing. That's what I think. Extreme downhill skiing. I'm going downhill left to right. That's where the extremes are, downhill skiing. Corny, I don't care if you use it. If you want to bust my chops about it, go ahead. Doesn't matter. But I have extremes and means. Next question. Once I calculate them, what do you do to them? I multiplied the means and I multiplied the extremes. Then what? Well, that's all I have. What do I do to these 2? Set them equal. And there's today's theorem. Here's today's new theorem, which is product. To you guys, that's what? Product. Product at my answer after I multiply. So the product of the means, when I multiply the means, product of the means equals, how do you think we're going to finish this? Product of the extremes. There's no shorthand either. So what am I trying to tell you? Suck it up. There's no pom equals po, if anyone's following that. Okay? It's product of the means equals product of the extremes. And that's how we're going to finish the proofs off today. Go that one extra step. All right, let's hop right into one. Don't worry about the givens or marking your diagram. Can you look at the proof statement for me? This is new, huh? I'm asking you to multiply a pair of sides and tell me it's equal to another pair of sides. This is means and extremes. Product of the means equals product of the extremes. Hold on. Stop. I can't cross multiply unless I have a what in front of me? A proportion. Keep going backwards. I can't have a proportion unless I know what about the triangles. Okay, everyone see the process now. I need to prove the triangle's similar so I can get a proportion so I can say the means and extremes are equal. So do you see, are you visualizing the last three steps of this proof? Prove them similar, build the proportion. Yesterday, that's what we did. Today, let's cross multiply. Now the big one is, what two triangles am I going to need here? Right? I got a ton in that diagram. What did we do yesterday to figure out the triangles I need? We're going to do the same thing today. Where are you looking to figure out what two triangles I need to prove similar? Or we're just going to guess. And hopefully we're right. No, I don't think I want to do that. Luke, where am I looking? Look at the proof statement. Ready? What's the first line segment in the proof statement? ER. Everyone look at ER. Is that a side in one and only one triangle in that diagram? Is ER a side in one triangle only? Yeah. Name it. Name it. Triangle. ERT. We found one of them. It's got to be that one because ER is only a side to that one. All right, name another side. Here we go. Name another side in my proof statement. Okay, here's where we run into a problem, right? AD. Ooh, could be ADT or it could be ADR. Everyone, I don't know. AD is not going to help me. Let's keep going. Name another segment. DT. Oh, now I know, right? DT combined with AD. I definitely see that triangle. All right, now I'm going to less group work and more me calling on numbers now. Angle, angle. Where is it? I need angle, angle if I'm going to prove them similar. Look at your givens. And you're welcome on this. I made it too easy for you probably at a class at this level. I made it too easy to at least find one pair of angles. But where do you see two pairs of angles that are congruent here? Talk to me. Let's hear from 15. Yep. I made it pretty easy. You don't even need to tell me the right angles. I already told you. You're welcome. TER congruent to ADT. All right angles congruent. Don't even need to mention their right angles. That's a first. All right, what about this isosceles deal? Let's see if you can give me another pair of angles. Give me another pair of angles, please, knowing now that triangle's isosceles. Let's get it. Let's get it. 16, any ideas?
Angle R is angle T.
Oh, my heart. I was with you with angle R, and then I dropped right off with angle T. I don't know. There's like 3 angle T's in that diagram.
Angle ATD.
I like that a lot better. Yep. ATD. Because they're across from the congruent sides, right? In a triangle. Or you could say isosceles triangle implies base angles. I saw a lot of you write that yesterday. That's fine. I'm fine with that. In a triangle, congruent angles are across from congruent sides. All right, I know now the triangles are similar. I got 2 pairs of angles. Great job, everybody. So triangle, just make sure we name them correctly, right? Let's see, if I go TER similar to ADT. Okay, here's where the confusion comes in now. Once the triangles are similar, what do I know about the, remember, just think yesterday, what do I know about the sides now? Because I can't just go say, this is true, means and extremes are equal. What did you guys tell me at the beginning of this proof? What do I need for me to be able to cross multiply? I need two ratios, a proportion. Here's where you got to set it up. Right after I prove the triangle's congruent. Now tell me the sides are the same ratio. All right, how can I build this? Look at the proof statement. Look at it. Name two sides you need to prove. Name two sides you need to multiply. T, ER, and AD. If I'm going to multiply them, where the heck should they be in my proportion then? Diagonal from each other. Where diagonal doesn't matter. So if I'm putting ER right here at the top left, AD's got to go bottom right. They have to be multiplied. So that's the only places I can put them. And the same thing works for TE and DT. They can go in either spot. What makes it true? Correct. Just like we did yesterday. Corresponding sides and similar triangles are proportional. Now we just add an extra step today. Now we add an extra step. Triangles are similar. Sides are in proportion. Now the means and extremes are equal. ER times AD equals TE times DT. Product of the means. Stretch out your wrist before you write this one. Equals product of the extremes. Any questions? All right, now it's time for me to go hands off and leave it to you and your group now. Again, first thing, determine the triangles that need to be proved similar. And then try to find both pairs of angles. Remember, it's a parallelogram. That's huge here. Go ahead. I'll come around, listen to you. Figure out the triangles that you need first. That's the toughest part. Make sure you all agree in your group what the two triangles are.
Wait, the big one, are you talking about this whole thing? Hey, how would it?
We tend to say SR.
Here you go. Make sure we got these two. Those are the two hopefully you and your group picked. Now use properties of a parallelogram to get angle.
Sides are parallel. This.
Can do alternate interior.
Alright, yeah, you said RS.
You have to say. Let's see
If your QC intersects,
Yeah.
You know that they'll diagonal congruent.
I think
They'll have to be.
Hey, wait,
Yeah, I know.
now,
Sometimes they.
RQ is parallel to SP.
I just have some.
when you can do angle
I suddenly have an idea now.
R
Why don't we set RQ and S and H equal, and sorry, not equal, parallel. And then like what we can do is that like we can set
Yeah. Wait, what means it?
these two
Because it intersects.
converting alternate
Oh,
interior.
really? So RQ.
Not the,
Yeah.
triangle.
Oh, that's right, never mind.
Let's try that. RQ is parallel to
QA.
SP.
So could you say RQ? Could you say B?
You say RQ is congruent to QT.
Or
B, right?
RQA.
Right.
Hence,
Technically,
parallel lines.
yeah, but it's parallel. In a parallelogram,
So, I can say that's RCQ.
Then it would be
So then we can define angle R.
Q,
AQ.
yeah.
From opposite angles. Beyond.
Yes.
Oh, we can't say QRS.
Say C and EQ. No, but then have to prove that QC is diagonal. So then it's just like CC Oh, yeah. I can.
Okay, what do you say? Why don't we start talking about the angles at least? Already up on the board. I think most groups probably did this. If not, it's fine. I did the opposite angles in a parallelogram or congruent. That's a property we learned last unit. Property is opposite angles in a parallelogram are congruent. Now, you could have went a couple different ways here. Take a look. You could have said these two angles were equal because they're alternate interior. If you didn't, that's okay, because you could have said, watch, the other pair, C congruent to AQP. Those are alternate interior. Either pair is fine. What would have mattered is what sides you put parallel. So let's say you put these two angles, C and AQB, then you would have had to told me that RS is parallel to QP. But if you said the other pair of alternate interior angles, you would have told me RQ parallel to SP. And I don't know if you guys remember from last unit, if you're always unsure, just write them both down. You're not going to be wrong. Parallel lines imply. No, I'm not ready for that yet. Just drew a blank right there. Should be what? Parallelogram implies opposite sides parallel. Then you tell me, based on what alternate interior angles you use, parallel lines imply alternate interior angles congruent. Angle, CSSTP, product of the means equals product of the extremes. Just make sure when you look at your proportion right now, look at your proportion you set up, make sure QC and QP are diagonal, make sure AQ and CR are diagonal. All right, if you're going to cross multiply it. Anything else on there? I don't need to write it all. All right, we got plenty of time here. Plenty of time to start practicing, especially on your algebra. Okay, so maybe, I know I start the homework off with proofs. Maybe you want to start with an algebra problem instead to see how you're doing. Get out your Chromebooks and get the answer key open so you know you're doing it correctly. At least somebody in your group or two people. Call me over if something's not looking right.